the IGAD improving, it's being recorded, improving global agricultural data session on the topic of platforms for agricultural data, how to address the fragmented landscape. Before we start, we have received so many interesting applications on this topic that we have actually decided to split that session into two, or to have yet another session. And the other one will take place on Thursday on 3 p.m. On this very channel here. So about platforms, I have been a little bit lazy or too busy to really look for a real definition of platforms. Of course, platform is one of the terms that has many different connotations. And if you look at data platforms, maybe there's a common theme or a common thread. It can still take like different forms and serve different purposes. Maybe a common theme might be that it convenes different stakeholders that produce, aggregate, and or contribute or consume data. So a platform might also have a certain geo or spatial aspect to it. And with that, yeah, it requires common metadata. It requires semantics and ideally common schemas, plus ideally also an application of fair data principles. I won't go any further into that because we will have 4 exciting speakers. Just a few words on myself. So my name is Lars Karnert. I work for the so-called Initiative for Sustainable Agricultural Supply Chains within GIZ, so the German Development Corporation. And my personal connection to that topic is related to agricultural agricultural production and sustainability data that primarily inform due diligence, but ideally can also serve other purposes such as data-driven farmer services, while empowering farmers through increased data access and ownership. And with that, we are within our program, we are currently embarking on a multi-stakeholder project looking into operability, predominantly around traceability for due diligence, but also forest monitoring and farm income. And if you see any overlap with your current work, please reach out so we can exchange ideas and maybe collaborate. And that was my brief personal advertisement. Coming to our session, I'm delighted that we have in our today's session, we have like really different aspects and different use cases, architectures, real case scenarios, including a study on data platforms. We have 4 exciting speakers that deal with the theme of data platforms from different angles. Before we start off, maybe, I don't know what is common practice here, but maybe housekeeping, I would propose that all of you, unless you're speaking, switch off your microphone, camera, I don't know, you can leave it on. Please post your questions into the chat, and we will run through all the 4 presentations, and we will discuss and answer the questions afterwards. So without further ado, I would like to welcome. No, first of all, let me thank very much Christopher. He unfortunately felt sick today and lost his voice. He's nevertheless with us. He was supposed to be the first speaker, and he kindly managed Nikos Kalatsis, whom I also want to thank for his short notice availability to take over, to present us the Plutos project, a common semantic model and data sharing agriculture. Nikos Kalatsis holds a diploma in physics and an MSc in information systems. He's currently working, here you can read it as well, so I started to read it. Currently working for Neuro Republic as a researcher in information systems and technical project manager For the last 15 years, he has participated in more than 20 R&D projects, both national and international. His major research interests lie in the field of Internet of Things, data modeling, and data interoperability, decision support algorithms, agri-food information systems, and agri-environmental monitoring. He has more than 40 publications on these research fields. So thank you very much. Nikos, the floor is yours, and please share your screen.
Thank you, Lars. I guess that you can see my slides, right?
Yes, we can see it.
Okay. So as Lars said, this presentation was initially organized for Christopher. Unfortunately, Christopher cannot present. He participates. However, we work together in the same project, so I hope I will manage to make this presentation as good as Christopher, although it's quite difficult because he's very good. So the outline for this presentation is that I will spend some slides in the beginning on the Plutos project. And then I'm going to present what is the motivation for implementing data sharing, and which are the use cases and the requirements that drove the design of our Plutos common semantic model and the data sharing architecture. We have implemented the various components for realizing data sharing, and so I will finish this presentation with some initial outcomes and some thoughts. So Plutos is about rebalancing agri-food value chain, and we are trying to do that by approaching three pillars. So combined, so we are attempting to implement behavioral innovation along with sustainable collaborative business models, and as a tool to the previous two, let's say, pillars, we have data-driven technology innovation, which is where we are going to elaborate. All these three pillars are supported by a sustainable innovation framework that actually it is evaluating what we have achieved in terms of innovation based on the mechanisms that we are implementing. The Plutos project, as I said, estimates and focuses on agri-food sector, and as you will see, the project. Before I proceed with more details, the project is funded by Horizon 2020. It started before 1 year, and now it is. We are in the heart of the implementation, and we have in front of us the realization of the use cases, and it consists of the 33 partners along 13 European countries with a wide variety of actors, including SMEs, NGOs, certification authorities, farmers, and food processors and retailers. So, as we all know, there is a need for data sharing in the agri-food sector. So, why we want to implement data sharing, and who are the key, let's say, actors in this? Of course, the key actors are the farmers, the traders, the processors, retailers, and consumers, which they are actively participate in the process of food production and food manufacturing and sharing. And we also have key players like food safety agencies and certifiers. The purpose is to monitor, especially in the context of the new CAP. Agriculture plays a significant role on sustainability and environmental protection. So we need to collect data during the production of of food in order to be able to evaluate the various policies that are implemented. There is also issues about promotional and reputation of the management purposes that are applied. So we have examples that farmers that apply sustainable practices, or food processors that again are compliant with good practices, may have a benefit in terms of market audience. And we have to enable, we have different value chain relations that are, let's say, supported by these mechanisms of data sharing. And of course, we have tracking and tracing of the various practices that are applied, and the location of the products that are produced, and all these support the optimization of the overall supply chain. Data sharing in agri-food sector is pursued for many years now. We have identified the following principles. First of all, we think that a core requirement is that the control of the data should remain at the hands of the stakeholders. So we consider that this is the only viable way for, let's say, having in a large scale the utilization of the various mechanisms that we are implementing. We have seen up to now, from our experience, that nobody wants to share the data in advance without knowing what will happen with this data. We need to have interoperability even with existing software systems. It's not viable to assume that in the future all software systems that participate in agri-food sector will be interoperable by design. There's so high complexity on such systems, where interoperability being, let's say, among the core design principles for a software system, again, it's getting difficult. Our last core principle is that we need to avoid vendor lock-in, and this means that the big, let's say, companies and that participate in the agri-food sector, they have somehow they are in a step in front, and they have the potential to dominate the domain. However, we all know that this is not among the best practices, and we somehow need to go to a standardized way, and not the big companies to let's say apply their standards. With regards to the Plutos project, we have 11 pilots. We call them sustainable innovation pilots. As you can see, all these are along many European countries, and they cover a wide area of food production, ranging from frozen fruit to crowdsourcing in order to create new food products, traceability solutions for greenhouses, carbon farming, and soil passport. Also, we have wineries within the consortium, and a very interesting use case in Serbia about trying to avoid food waste by facilitating the transfer of surplus food from farms to social disadvantaged groups. For the needs of our organizing our work in the technical part on implementing the data sharing mechanisms, we focused on one of these scenarios, and then now we are in a position that we have finished with implementation of the core components, and then we are going to apply the similar mechanisms to other SIPs. So the first pilot case that was our let's say example pilot was in Greece, taking place in Greece, and it includes peach farming and farmers that they have they manage orchards with peaches, and the overall concept is that we are applying the necessary technical mechanisms in order to proceed with an optimization of the farming practices in terms of pesticides, fertilizers, and irrigations. We do that by collecting data from the farm along with agricultural practices. We have deployed IoT stations and also digital calendars for the farmers. We give all this data to algorithms in order to have advices. The next step of the food chain is that after the harvesting of the peaches, they are transferred to a food processing company, which is essentially what it does is that processes the peaches by washes them, peels them, cutting them in cubes, frozen them, and exports them to some EU countries. Among the objectives of both the processing farm company and the farmers is to get certificates on global GAP for good agricultural practices. So through this, through the data sharing mechanism that we have implemented in Plutos, we are trying to facilitate this process and to implement a traceability service according to the principles that I just presented. And you will see more details in the next slide. So the way we analyzed all the SIPs was that we're trying to answer some core questions that are applicable for all the SIPs. You can see here some of these questions. For example, who owns farm X, where the food products, the fruits are produced? What are the exact parcels that belong to the farm? Are peaches a fruit, or how we can express the location of the farm? So this was these questions drive our, let's say, the design of the data sharing mechanism that we implemented. The breaking down, let's say, the traceability questions that a potential consumer might have is that from what farm does batch X of frozen fruits originates? What are on what measurements a certificate Y for batch X is based? And of course, questions about pesticides, fertilizers, and irrigations that have been used in order to produce the peaches that later have been processed and to reach the consumer in the supermarket. So the first issue we tried to address was semantic interoperability. So we did that with the use of a common semantic, the Plutos common semantic model. It is based on standard ontology engineering principles. So we tried to adapt RDF and all. We don't want to create a new ontology. We're trying to maximal reuse of existing to reuse existing ontologies on a maximal level. And the idea is that the PCSM, the Plutos Common Semantic Model, is based on a core model that covers the main common concepts of agri-food domain and is feasible to, let's say, reuse in a modular way existing ontologies that are focusing on other specific domains. The first version of the ontology is available in the link that you can see here. And some common concepts that we have identified as the core concepts that are useful for all the SIPs, but also for the agri-food sector in general, are related with farmer, farm, parcel, crop, It's about material that are participate in the food production, in agri-food, in soil, fertilizer, pesticide, and actions that are performed by farmers or food processors, and of course, environmental related concepts. So we tried to review and identify which are the dominant ontologies in these areas, and we concluded in this ontologies that you can see here, and we modularly used them in order to model the various information entities and concepts that are useful for the realization of the use case. Now, this was the way that we addressed the semantic interoperability. Now that we have a common meaning for the data, we also implemented mechanisms for exchanging data. So before we proceed with the implementation, we identified some core technical requirements, or as we see here, Pluto's architecture core principles. Of course, in the top of this list is semantic and syntactic interoperability. As I said before, we are not foresee that we are going to substitute all existing information systems that participate in the agri-food sector, but rather we are going to integrate on them in a seamless way, or in a more, let's say, light way as possible. We would like to avoid a centralized approach, so we need to make each information system discoverable, and also to comply with core security requirements that has to do with confidentiality and integrity. A conceptual view of what we have done in Plutos. So here you see some indicative participants of the agri-food sector. Of course, we have in the bottom of all this the farm, where the fruits or the vegetables are cultivated and produced. So as I said here, we have the farm management information system. We have also a certification authority that audits the practices that are applied in the processing factory and in the farm in order to conclude on the good agricultural practices. We have the processing factory. In our case, is a frozen fruit factory, as I said before. And we have different information systems. Among them, we have a consumer application, where the typical scenario that the consumer scans the QR code or the barcode of the product and is able to trace back what the history of this item. So what we are doing is that we are introducing the Pluto's interoperability enablers. So it's these lightweight software components that are deployed on top of existing information systems. And we have a directory service. We call this Pluto's registration and discovery directory, where essentially what it happens is that each PI, the Pluto's interoperability enabler, demonstrates its existence to this directory service, and at the first stage. And then there is the possibility, let's say, the functionality that a PI may issue a query to another PI about an information item that is interested in. So we see that information does not leave from each source in advance, and there is also the right of an information holder to filter or to deny, let's say, or to grant access to this to the queried information. Some more technical details that are available in our deliverables on how we have implemented the Pluto's interoperability enabler. At the heart of this system is a translator service, which is custom to its underlying system. So essentially what we do is that we get data from the underlying system. Of course, there is a need for an API or another way that to get the data from the existing system. We translate this data according to the standard and the ontologies which I just presented, and make this available through a standardized Spatial API. Excuse me, how many minutes do I have?
Just go on. Just take your time.
Okay. 1 minute.
2-3 minutes.
Okay, so I will conclude. Again, as I said before, the registration and discovery directory has the role of a directory. So each SPI demonstrates its existence, and it is accessible from this directory service. Here you can see the conceptual, let's say, representation of our first use case that we are implementing, where you see the sequence of the information flow based on the lot ID that is typed on the box of the final product. It is feasible through this combination of modules to retrieve information on the practices that have been applied during the processing, on the practices that have been applied during the cultivation. And all these are mediated through at the first stage, at least, through the directory. Some final issues to think about, and this is from Christopher, that our vision is food tracing to be integration with of the various information systems that are holding information on food production to be as simple as an email, having standards in the way that the actual information is modeled and is transferred. Of course, as always, we have privacy and confidentiality that is on top of these issues, and we need to go for standards that are universally accepted, if possible, to avoid vendor lock-in. And this is from my side. Sorry if I took more minutes.
Thank you very much. It has been very, very exciting, and I didn't want to stop you. And please, everybody, please post your questions in the chat. I would definitely like to follow up with you. I really liked it very much. But we need to move to the next session, and I would like to, and we will discuss later on, as I said. Let me kindly ask Casten Hoffmann on the stage, who will present us the bonoriz repository, fair research data management for agriculture. And here you see his brief bio. So he works for the ZALF, the Leibniz Zentrum für Agrarlandschaftsforschung. Please.
Yes, thank you. Thank you that I get the opportunity to give the latest news from the bonoriz repository. And my name is Casten Hoffmann from the ZALF Müncheberg. I'm part of the team, and we develop the data repository to manage research data which are coming from the bonoriz project. And I want to give you a short introduction to the project bonoriz.
Sorry, 1 second. Maybe you can we still see the presenter view. If you shift views, then we see the full screen.
Okay.
Maybe under Anzeigeeinstellungen. But anyway, just go ahead. I don't want to confirm. Up there you have Anzeigeeinstellungen, and then you this one vertauschen. Exactly. Thank you.
Thanks. bonoriz is a large project in Germany with a quite long running time. So we were launched in 2015, and almost a running time of 10 years, plus a perpetuation in the end. So we are almost in the last phase of this project. And to this project, they are belonging 16 collaborative projects with different tasks according to soil research and the rhizospheres. And as you see in the map, there are more than 50 institutes in Germany involved. And because all smaller and mid-large projects produce a lot of data, it was decided to set up a repository to collect all this data and provide them for the scientific community. And so our part is in the bonoriz Center, where we develop the data repository, which I will show you now and show you the latest tools we have developed so far. So just to give you an introduction to our principles, what we plan to do or what we did and we want to perpetuate in the end. So data which are achieved within this project must be open and visible for the community. The data must be legally sound, so the author's rights must be respected, of course. The data we are achieved from the projects should be aggregated usefully, and we also, this is a part of the last phases of this project, should be also quality approved. And even we are a national project, of course, we want to provide data which are harmonized on the international context. So all these words or phrases you see here, of course, fit with the quite famous fair data principles, and give you a very short overview which of the how we address the 4 letters: findable, accessible, interoperable, and reusable within our data center. So to be findable, of course, we should provide persistent identifier, and also in the metadata. And here we support identifiers for crop varieties, for instance. We use international crop codes from the FAO. One, of course, very important PID is the ORCID, and we also are connected to the DOI system. Coming to the next point, accessible. So data must be described by rich metadata. So we developed our metadata scheme, which combines all mandatory elements from the Inspire scheme and also the DataSite scheme, and this was extended by the bonoriz, important elements from the bonoriz project. And these metadata are able to be harvested between different systems. Coming to the interoperability, so we use controlled vocabularies. Most important, of course, is the agrovoc, where we allocate keywords to the data sets. And what is recently in the preparation is to use also the ontology of measures, which we have heard also in the presentation before. And the last is reusability. So license must be regulated, and we should use community standards. And here are some examples. So for our geodata presentation, we use the OGC standards. So OGC standard is widely used and an open standard for soil classification, of course, WRB, but also national standard, the KA. We recommend to use common laboratory methods, which are described in ISO standards, for instance. And for the licensing, we integrated the Creative Commons standards. Oops, sorry. So just in short, to show you the data lifecycle in our repository or in our project. So if you have a soil scientist, he selects or she selects a soil sample, makes a data preparation, analysis, and in the end, this data should be published. And from this publication, new research questions appear. And what is our task here is that the data should be, after the publication, be uploaded to the bonoriz repository, that this data can be reused by other scientists. And I will show you now in this presentation the steps of our working flows. Here is a collection of our tools we developed. I will go through the tools, for instance, the data quality tool, which is recently in preparation, the upload tool, how we collect the metadata. Then what is very interesting, of course, and important for agricultural scientists are long-term experiments as data treasures. And the data provision is as given by our bonoriz repository. And the last two, the IGAD tool and soil files, this would be too much for this short presentation. So if you're interested here, I can show you in the end some extra slides. Coming to the data quality. So data quality, of course, is important. The data are provide a certain trustworthiness, and we decide between two different data quality types. First is the formal data quality, so the data should be SQL conform to fit into our database. And the second is that we need, of course, a kind of content-related requirements. So data should be plausible, statistically sound, complete, and so on. And here I show you some examples which we are until now do manually, including a feedback with the data provider. So if we have here a data set with the seed weight, for instance, and if we check this data, we see one point is minus, so seed weight in kilogram per hectare is not plausible to have a negative value. So here we give a feedback to the data provider. Or a second example here is an outlier. So this is all manually, and as you can imagine, quite time consuming. So what we are doing now is to develop a tool which provide automatic tests for the data provider, where they can check their data before they upload them to our repository. The second tool is the data upload tool in our repository. This is quite user-friendly in my eyes, so you can just visit our homepage, click on data submission, and then you are involved to a ticket system, and you upload your data, and also the first metadata are already captured by this method. And here we have the chance to edit this, or to have an editorial system for the data provider. And the data provider always get information about the recent status of their data set. The next tool is our metadata editor. So we describe, or the data sets should be described by rich metadata. As I told you, our scheme involved the inspire and data side elements to increase the findability and interoperability of the data sets. And within this editor, the data provider are able to give all the important information for the data sets, including the methods which are used, the units, and so on. And some elements just to click down by a drop-down menu, for instance, the license. So we recommend to give the license CC BY for research data. For metadata, it's mandatory to provide them in open access by CC0. And within this metadata editor, you are also able to annotate your data set by AgroVoc keywords, which is connected by an API. Coming to the next tool is the long-term experiment overview map. So recently we collected metadata from more than 600 long-term experiments. What is a long-term experiment in our definition? So the running time must be more than 20 years, and there should be a research question behind, something like a fertilizing experiment for 30 years or more. And this is quite important for the research, because by this data you get information for any other research questions. And within our overview map, the researchers have the possibility to find the location, the research question of a long-term field experiment, and also contact address and so on. And about this feature, we will have a presentation on Thursday by my colleague Nico Svoboda. And the last I would like to show you is the bonoriz repository. This is let's say the portal of our repository. So you can search and find your data sets you are interested in. For example, by AgroVoc thesaurus search. and it's quite easy if you find a data set to download this via an Excel sheet or in other formats, and you can you have all the information you need, for instance the license information. And with this last slide, I would just give you an overview how we are, because we are a national project. So our first task is to work with the bonoriz community. We are open, but we are also open for other national and international data sets. And in the future, we will be more and more connected to international initiatives. And you're quite welcome to contact us and ask us how you can use our repository or contribute to our network. And with these words, I would like to say thank you, and I'm looking forward to your questions.
Thank you very much, Casten. I think you could have elaborated on all the different aspects for quite some more time. Very interesting. Sorry for only having given you 15 minutes, but please post your questions into the chat. And with that, thank you very much, and a big applause again for Casten. I would like to come to the next presentation already, which is on a different aspect. It's on a study in Nigeria. I would like to ask to the stage, so to say, Michael Ikehi from the University of Nigeria, Nsukka, on a study on agricultural research output and the issues of data sharing with the extension service in Nigeria. You see his brief bio in the chat, kindly posted by Chelsea. And with that, I would like to hand over to you, Michael. Can you share your slides, please?
Yes. Okay. Okay, thank you very much. The study focuses on agricultural data. So research institutions are usually center for data generation. So these data they generate for agriculture often contain innovation, strategies, best practices, and programs. So the aim of this data is often to guide farmers and as well provide policy direction for agencies responsible for farming. But you find that this data, especially from research institutions, upon generation are disseminated or rather reserved or sent to favorable publishing houses where these data are kept in databases. So it becomes a problem for users, direct users of this data like extension service, who also are the bridge to farmers when they want to access this data. So there's a problem of accessibility of data. And secondly, the form in which the data is available to the extension agents. They are not as educated or as sophisticated as the scholars. So these data are somewhat in high forms that they cannot interpret. First of all, they cannot access freely. And whenever they can access it, it's not in a form they can understand. A good data is supposed to be one which the user or the middleman between the user can interpret and provide a feedback back to the source so that the source can make modifications if there are needs for it. But you find a situation where users like the farmer and the extension agents are first of all finding it difficult to access this published data. And when they can access the data, there is no way of providing feedback to the research institution directly or indirectly. So there's a bridge between the data source and the data users. So the lack of direct data sharing between research institutions and the end users like extension services and farmers is basically the worry of this study. So we looked at the following questions like, what is the preferred reader access choice when publishing findings from these research institutions when data is ready after finishing a research work and they want to publish? What nature of publication are they often interested in? Secondly, what is your first point of action when you complete a research work conference or workshop with an output recommendation for improving agriculture? Then what are the channels for dissemination of research findings by agricultural scholars? I also looked at what are the factors influencing the choice of channels for disseminating of research findings, and what are the sources of updating information from research by extension service. Then finally, what are the problems of data sharing between research centers and extension service? So this study was a mixed method research, and I relied on both primary and secondary data. So for the secondary data, it was generated by a review of 100 randomly selected studies. And for primary data, it was a survey which was collected using the structured questionnaire. And the questionnaire was phase validated by 5 experts. They were contacted on ResearchGate. Research questions had reliability index of 0.87 and 0.86. So the scholars questionnaire was sent to 54 contacted lecturers in agriculture. Then 76 of the extension agents questionnaire was sent out. However, only 43 was sent back from the extension service. So I used simple percentage frequency count and mean to analyze the data. In results, so the first question which was posed initially was the preferred access choice while publishing. If you look at the table, you find that the evaluation of 100 randomly selected publications in agriculture in Nigeria. They were published in closed access journals, closed access international journals. That is the major source of publication. Then, what is the first point of action when you complete a research work or conference or workshop with a recommendation for improving agriculture? You find that seeking out publishing firm is the first point. And we looked at the most popular channel for publishing of scholarly findings. Out of the 150 respondents, 87 of them indicated to publish through international journals. And when we checked out also reasons for choosing the channel, 103 indicated the requirement for promotion. So we are faced in Nigeria with a problem where scholars are more interested in getting their work published and being recognized for promotion. So the question is, if these data are sent out for promotion and they are in closed access journals, how are they supposed to get to, or rather, how is the farmer or the extension agent supposed to access this data if they are deposited in repositories with closed access? Then the sources of updating information from research by extension service. It is assumed that new information are generated annually from these research institutions like universities of agriculture. These information generated are supposed to go down to the end users, like the farmer and the extension agents. But the extension agents only update their source of information for teaching the farmers, mainly through the extension manual. The scientific journal is actually the lead source for checking modern or recent information. So when I compare this with the most popular channel for publishing, there seems to be a contraction. While the extension manual is the main source of updating information. The information needed are often published in international journals. So there's a problem between data source, generation and usage of such data. So when I compared the mean value of respondents on problems of data sharing between research centers and extension agents, most of the respondents indicated that poor policy drive for data sharing is the major problem. Subsequently, you have a bureaucratic bottlenecks, meaning the extension agents, when they try to assess this information, they are met with certain challenges. And of course, they have not been able to overcome it. So they continue to rely on existing information rather than current information for improving farming. And the least was the misalignment of research output with reality. I also tested the possibility of if the actual studies in the research sector is addressing the physical problem in agriculture. It happens to be the least favored source of problems for data sharing. So in conclusion, it's one thing to generate data and it's another to ensure the generated data is accessible and useful to the end users. So a generated yet unaccessible data is a dormant one. Scholars need to understand this. It is not good enough that you have publications, you see a problem in agriculture, you generate data to solve the problem. But if that data is not accessible to the end users, you have not really solved a problem. So in recommendation, provision of funds for data curation and sharing activities, it happens that these scholars often point to inability to fund hosting agents for their data, like most of my colleagues who presented, where the governments are now funding repository where such data are deposited and they are made available. It is not existing. So it's a problem that needs to be addressed for us down here in Africa, in Nigeria specifically. Then development of policy and framework to encourage sharing of data between research institutions and extension services, especially during updates of training manuals. If the extension agents often get their updates on agricultural practices, recent practices from extension manual, there should be a kind of framework or policy to mandate a relationship between research bodies and extension service, so that when these manuals are being updated to solve recent problems, the current findings from recent research are included, and such are also transmitted down to the farmers to ensure continuous practice of modern farming. Then there's also the need to increase funding for dissemination of agricultural data by research institutions like universities of agriculture to ensure the published data remains open access. One problem with publishing is the cost of publication, especially when they are choosing international journals. These journals are highly priced for a good data to be published. Now, when they are published, they remain closed access. So even when an educated extension agent is trying to update information in agriculture, personally, he's also faced with inability to access the data if it's published in other international or even some local journals where they are supposed to be made available. Thank you very much for listening.
Thank you very much, Michael, for sharing your insights on your study on data for agricultural extension, which is obviously quite an untapped potential here. Thank you very much. I think we will have a lot to discuss afterwards, after the session.
Thank you.
And with that, I would like to ask for our last but not least speaker for today, which is Jan Willem van Kasteren, who will introduce a supply chain management platform in Uganda from data warehouse to big data. Jan Willem, so this is as far as I understand, this is also a real use case of a data platform. Jan Willem, please come on stage and share your screen. Jan Willem, I've seen you
Hi.
before.
Sorry.
Hey, here
Yes.
you are.
I'm in Ivory Coast, and
You're okay.
very.
You're still on the move.
It's very difficult to. Can you hear me?
Yes, we can hear you well.
Good. So let me share my screen. Sorry, I just joined in. Okay, I hope you can see my screen.
Yes, wonderful.
That's great. So, yeah, thanks a lot for this opportunity. My name is Jan Willem van Casten. I'm the founder and director of Eplot Solutions. We developed a platform to manage sourcing from large numbers of small-scale farmers for a company that I started in 2004. And this company was sourcing from about 8,000 farmers, organized in hundreds of groups. And we needed a platform to organize the contracts, field inspections, collections, payments, traceability, reporting. About 5 years ago, we decided to commercialize it when we noticed that most cooperatives, after all these years, still work on very simple paper-based systems, or they might use very rudimentary computerized systems like an Excel sheet, or maybe do mobile payment, but individually they might do surveys through ODK, but it's all disintegrated and very difficult to scale. Therefore, we saw the opportunity to commercialize the platform that we have developed for the other company. And we target the food processors, the traders, the farmer cooperatives, and we offer it as an off-the-shelf platform, which helps us to keep it very affordable. And basically, it means that all the clients have the same platform, even though we do a few times a year, we have a new production release, of course. But this makes it very easy for us to deploy the system very fast, and also to basically have the clients up and running within literally a week or so. So the system is really optimized for areas where the internet is very poor. So it can synchronize in 2G networks, and it can also work fully offline. Then, of course, there's a lot of data in the system. I will talk a little bit more about it. So basically, we have a mobile application and a desktop application. The desktop application has far more functionality. The mobile app is really designed for the people in the field. So we can integrate hardware like weighing scales, scanners, measurement equipment, like for example, to test the quality of the milk, or printers to print receipt for farmers. We can integrate with banking software or financial accounting software like Sage, QuickBooks, Tally, because we don't offer that part, but then others are specialized in that. But our platform is optimized, for example, to make very large numbers of small transactions. So we can basically integrate that either through API or simply export the form that can be imported then in the other system. We can also integrate with services like weather forecast that we then push through localized SMS for a specific field, for example, or we do weather agronomic data, for example, with models from Africa Rice, or with IITA or Wageningen University that have specialized models. Now, because we have so many different modules in the system, we can bundle these different modules. So basically combine the modules and then offer like a bundled service. So for example, if the objective of the cooperative is to increase the yield of the farmers, they might need access to finance for that. In order to create access to finance, credit scoring data, KYC needs to be shared. Then farmers need to give a consent step that can be through USSD, for example. Then the loan application itself can be processed. The physical distribution of the inputs can be done through Eplot app by the mobile people, by the people in the field. Sorry, there's a lot of noise at the background. Then the risks can be reduced by sharing weather information or other information, easy communication, contract management. So all this can be combined, and then this bundle of services can help that also innovations can be introduced successfully. Now, what we can also offer to strategic partners, like for example, NGOs, that information from different cooperatives, for example, or different Eplot users is combined in a data warehouse where then information is shared. You could simply plug in a business intelligence tool like Tableau or Power BI, or we integrate it with an ERP that, for example, a larger processor is working with, or a banking system, or an NGO, for example. Now, we have a specific case in Uganda where we support 5 coffee cooperatives, coffee farmer cooperatives. They work with one organization, one buyer called Kampala Domestic Stores, or KDS. They need information from farmers, for example, specifically for yield forecasting. So we're still in early stages, but in Eplot, you can make simple yield forecasting by making crop estimates or yield estimates at the individual field level. This, of course, can be integrated. In the future, we want to make this more advanced by working with coffee crop forecasting models from IITA, for example. But at the moment, we do it relatively simple. So at field level, you can make a crop estimate, and this can be then aggregated to give a yield forecast. So in this case, we also work with the Buganda Kingdom, which is a large part of Uganda, which is still somehow under a king. So there's a
Jan Willem, at least I cannot hear you
some
anymore.
of the farmers in that area.
Okay.
Then you cannot hear me?
There was just a small gap, but now you're back.
Okay, sorry, I see the connection is a bit unstable. So I was saying that so we have different organizations that want to use the information. So for example, KDS is a trader, they need yield forecasting. There's an NGO called Bukadev. They need socioeconomic information because they are supporting people in a certain area of coffee growers. The traders and also the cooperatives, they need certification data, for example, for UTS certification. There is a bank, DFCU, that needs information for credit scoring. So in this case, we combine this and we give different people access to that data. So this is also a relatively new area for us. We have done this now for a couple of years, mainly with NGOs. But it's very interesting for us to work with strategic partners that often have contacts with many companies in the private sector. And yeah, this is why this is really strategically important for us. So as a company, we normally just work business to business. But because of this strategic interest, we can also do this with NGOs, like for example, with in the case of GIZ, we are discussing this to do this in Ivory Coast. Great, thank you very much.
Thank you very much, Jan Willem, for your insights into the Eplot platform. And with that, we have reached the end of our presentations, and I'm looking forward to receiving questions from the audience to all of our 4 speakers. So just to recap, we have heard Nikos presenting the Plutos architecture, followed by Casten on the bonoriz repository on soil data, followed by Michael on a study on using research data for agricultural extension in Nigeria, and Jan Willem with the Eplot platform. So we have had one question, but as far as I see, this has been, or two questions by Josep Pijuan, but as far as I understand, they have already been answered in the chat directly. So I'm wondering if anybody else from the audience has something to ask or to comment on our presentations. This is not the case. Nobody? Any comments? I think we have really seen kind of really different presentations, different cases here. If this is not the case, I would like to ask a question to Nikos, if I may, which is non-technical, but from what I've seen in one of your last slides, you said you want to have the system as open and as scalable as email. And you had these different use cases that you presented. So I'm actually wondering, in terms of transferability, or if you want scalability of this really interesting concept, what does it actually concretely mean right now to transfer it from a Cypriotic wine to whatever, cotton from Burkina Faso or coffee in Colombia?
Yeah. So the idea is to be able to adapt with as much less effort as possible. So all the components, we're trying the components to remain the same in all cases, but what we need is that just to extend our translators. So in case we have an API that exports data, it's just a matter of extending the ontology and the translator, not rebuilding a new system from the beginning. So we already did that for, as I said, for Greek farmers that they are producing peaches. We are also doing that for vineyards in Cyprus. And from what we see until now, it's more a problem that some systems, they don't really have an API yet. But so there is no way to get the data in online manner. So this was our main problem. So it's not so much difficult for us to extend the ontology with the right concepts in order to address different cultivations or new active substances or new fertilizers or different way of cultivation practices. This is, let's say, the easy way. Our main problem right now is that there are no information systems, at least in South Europe, that are having this information from the beginning.
Okay, thank you. That brings us to another question, maybe to all of you. We have platforms always, of course, have a comprehensive, let's say, claim, if you want. So Cynthia said, while it seems we have good approaches to build tools that allow for sharing across different platforms, this may now be creating the same problems at a higher level. How will all these platforms now talk to each other? Maybe that's a question that goes to all of you. And of course, one would see could be interesting to look for integrations even between the platforms. So that question would go to all of you. Do you want to comment on that? Or are you already the super platform? Anybody else from the speakers who wants to comment on that?
I can take again this question if nobody else. I think it's again a matter of standards. So even if we discuss about cross-platform interoperability and not cross-farmer system interoperability, it's again the same requirements. We need syntactic and syntactic interoperability. We need APIs in order to find a way to transfer the data, but we need a common meaning also for the data. So I think that the same requirements that apply for the farmers and the platforms they are using apply also for the data platform among them. And of course, we need a harmonized way for access control and security, where again, we do have some good dominant approaches like zero auth and things like that. I don't know what the rest think.
We already have an answer to it all. So if all had Sparkle, we could run federated queries. As simple as that. Any of the other presenters who want to comment on this question? Jan Willem, how would you collaborate with Plutos?
In this case, yeah, we could also, of course, we have the APIs, so we need to, yeah, I think we need to just sit down and see where it would make sense to share information. But technically, that would be possible. And maybe to give an example why this interoperability is so important. I'm at the moment in Ivory Coast, and we see that the cocoa board basically in Ivory Coast is developing its own traceability system. They're very secretive about it. Even the donors, I just come from a meeting with the European Union, and yesterday I had a meeting with GIZ. Both are co-funding this development, but they're not really kept into the loop. What the status is, and it looks like a local company will develop it that might not have the capacity. It will be a kind of platform that should solve all the problems in the cocoa sector, which likely will not succeed. We have seen similar cases with traceability systems in Kenya for the vegetable exporters. This also failed. So it would be very good to lobby for this interoperability and have generic systems where there is also some choice for the users, the farmer cooperatives, the traders, for example, or ministries or other stakeholders, and just have a clear integrated approach. That would be the way forward.
Yeah, exactly, and maybe that's just an example, a bad example of still trying to run for centralized systems rather than what Nikos proposed to make it as decentral as possible. We do have a question for Michael Ikehi. How could these platforms begin to meet the needs of extension agents? Is it open access enough?
Open access is at least the point of starting to address the problem. Extension agents are built to collect information from the sources where the data is generated. So the interface between the source of data and the end users, who are the farmers. So the first point is for them to have access to data. So having access is not enough, yes, but it is the first point. If those data are not available, they cannot move to the next stage of solving agricultural problem. Research has been publishing, or rather academicians have been publishing research findings. Most of these findings propose to solve a problem. These problems are experienced by the end users, who are the farmers. So there seems to be a disconnect. The information is generated and disseminated in another direction. The extension service are interfacing with the farmers, but do not have the information to modify practices, and especially climate change issues. If these data are made at least open access, or a kind of policy framework to ensure that research data from institutions find a way to get to extension service, it will solve at least 50% of the problem. Let it be that the next phase will be the implementation of the strategies, but let there be access to this data before we can talk about the next stage. Most of my colleagues presented a situation where a repository is being developed. This repository is likely to collect data from different sources, likely make it open access and available to users. So you see that they have started solving the problem already. The research is busy conducting its research. The repository is gathering research from different aspects of the country to solve agricultural problem. The extension service will now be beefed up to have access to this data. Translate this data in a form that the farmers can understand, can use, and probably run pilot tests and studies for the farmers and transmit the current, or rather futuristic approach to handling problems in agriculture. So yes, making it open access is not enough, but it is the first point where we can begin to solve subsequent problems. Yeah, thank you.
Yeah, thank you. We haven't heard from Casten as yet, so we have actually connected. We have successfully connected Eplot with Plutos. But how does it relate with bonoriz? I think that could be relatively straightforward. But do you want to allude on that as well, Casten? And maybe to add to that, I've understood your current geographic scope is it restricted to Germany, or do you go beyond?
Actually, this was the last slide, that we are more project involved, so which is a German project. But if someone external from Germany or from Europe or anywhere else asks us to publish their data, okay, we do not say no, but as you can imagine, it takes some time for data curation, and so we are not generally open to all, because it's also time consuming to create the data sets. Actually, to your question, connecting to Plutos, I cannot really give an answer. This is not in our framework now to getting connected to other. What we are doing is, of course, we are collecting the rich metadata, so we are able to harvest other systems and also harvestable from other systems. So if you enter a certain data platform and search for a data set, you may be able to get connection to our data as well. So this is a little bit the idea also of our decentralized system, that we not have one large platform, but many smaller one, and via the metadata, you get access between different platforms. So this is our strategy in this task.
Yeah. Okay. Thank you. I would maybe, if somebody, I lost a little bit track of the question. So if somebody, I don't know, Cynthia, you posted a couple of comments here. If you want to speak up and maybe show your face, please do so.
Can you see me?
Yes.
Okay, good. No, I'm just following the discussion, and I'm struck by a few things. Number one, the importance of standards. And so even if we could do a single Sparkle query across all of these platforms, that would still require at least some consistency in vocabulary and how we capture the raw data. And then I'm thinking a lot about Dr. Ikei's message about the value of all of this data for extension and actually translating this raw data into something that farmers can actually use. So I'm wondering if there's some opportunity here that if, you know, as we get more and more interoperable, that we can perhaps work with extension agents to figure out how they search, what they're looking for, what form they actually need the information to be in, so that they don't have to do all the work themselves. So I'm very inspired by all of this. I think we're seeing lots of progress, and I think we're asking the right question.
Yeah, thank you very much. That was a question I didn't actually dare to ask, but I mean that's the question of data formats, etc., with regards to extension coming out of agricultural research in order to make it shareable, interoperable, etc. Do you have an idea on that, Michael?
Oh, okay. In Nigerian context, there is no framework existing at the moment. So this is part of my advocacy. This is part of what I'm really concerned about. How do we get the research institutions and the farmers or the extension agents to sit together, especially the extension agents and the research institution, and have a kind of discussion. What kind of data do you look for? How do you get this data? Where can we come in? She pointed it out when she highlighted distance. So the thing is, whether the data is open access or not, what kind of data do you search for? How do you get it? But in a situation where this is not possible for bureaucratic reasons or funding problems or whatever the problem might be, some of these extension agents are coming up to speed in terms of learning and reading and writing and using internet to solve certain problem. I have interacted with an extension agent who said a farmer came and asked him a very serious question about practices. He couldn't provide a recent answer. So he told the farmer, please meet me tomorrow. Let's discuss it tomorrow, and gave him an excuse of having another appointment. But he went ahead to search on the internet. He found quite a good number of articles on such topics, but to his surprise, they are all closed access. So even if we don't look at a structured system where intellectual findings transmit directly in a form consumable by the extension agents, when the extension agents can make out time by themselves to sort out these problems without being guided by the research institution, these data should be made available at least. Let them aggregate the data in a way possible, in a way the farmers they mediate can actually understand, at least to a level of trial and error before practicing over time, then the solution can come up. So for now, there is no structure, and that is part of my personal advocacy.
Okay, so I understand that you're working on a structure which would be good. And as Alvaro also mentioned, it would be interesting an extension agent to present how they relate or not with this universe of platforms, and work on a structure especially geared towards agricultural extension. And thanks for volunteering, Michael.
Thank you.
Okay, I don't know if I've missed any further comment here. Can somebody help me?
Maybe there's one question in the chat I've recognized from Scout Calvert. He wonders how we can involve the stakeholders into
Yes.
the progress of giving their data. And so from my view, I can give a short comment from the research. So we address 95-99% the research. What we are doing since the beginning is that we give data workshops, which takes sometimes one day. So make a training with the researchers to train them how they have to prepare the data set and how they have to give their metadata, and also to make them more sensible for the importance to make their data in open access. And this is very hard, as you can imagine, very hard process. So we are now working since 2015, almost 7 years on this, and it takes long time to going to the researchers and ask them to spend some time to prepare their data. But it's step by step, it's getting better and better. That's the view from the research.
Okay, thank you very much, Casten, for picking that question, which unfortunately I've overlooked. Does anybody else of the presenters feel like answering that? So how to get stakeholders involved and what the challenges are? Nikos?
Well, I'm sorry, but I'm not. If I'm not getting correct, how do we get stakeholders that are participating in the whole life cycle of data, generation and sharing and things like that? Is this question?
Possibly. I think you all have like different situations where I think maybe Casten is eager in collecting data, and you're more working with particular use cases or supply chains. But I, as far as I understand, it's about gathering data, getting stakeholders involved in the project.
Okay.
Maybe if you look at individual projects you have within particular use cases, how to get the actors involved.
Well,
that would be interesting.
At least from my experience in these EU-funded projects like Horizon and 2020 and Horizon Europe, we call this co-creation process, where we, from an early stage in the project, we have participants that represent different stakeholders of the entire ecosystem, let's say. So at least in Plutos, we have from simple farmers that they have no idea about data sharing, to universities or organizations that are working on standards for data sharing, but also food retailers or food processors that they do care about data, but they don't know how to get them. So through this integrated process, having participants from all, let's say, all the representatives that participate in the information lifecycle, each one is contributing with her own view and the requirements they have on data sharing. So at least this is the way at least we work in Plutos.
Okay, so thank you very much. Jan Willem, you also want to add something?
Yeah, maybe I can make just a comment for us. I mean, we're very much private sector driven. For us, I think the best way to push for this interoperability is by applying a market systems development approach. In the case the banks need data and it has value for them, in case the farmers see the value in extension services, make sure they're willing to pay for it. If the trader needs certification, they're willing to pay for it. So I would really say a market systems approach is preferred for a quick uptake and a full uptake of these integrations.
Okay, yeah, thank you for this perspective, Jan Willem. And unfortunately, I've completely forgotten to look at the time, so we're already over time, and we could have. Thank you very much to all the presenters and the interesting discussion to all of you. We could have gone on for quite some time. But the good thing is that there will be a part 2 of this session, and we will have even more use cases on. And stay tuned, and please join us again on Thursday at 3 p.m. UTC for the part 2. And with that, thank you all again for all the presenters and for listening and for contributing to the discussion. And see you next time. Thank you.